All right, so here's what I saw from a lot of kids today in class. They would draw a molecule, something like carbon dioxide. So you'd have carbon bonded to an oxygen, bonded to another oxygen, and then there would be 1, 2, 3, 4, 5, 6 electrons. 1, 2, 3, 4, 5, 6 electrons. And then they would say, there you go, it's done. Carbon there is only touching how many electrons? It's only touching 4 electrons. So it's not okay. Carbon needs to touch 8 electrons. That's the octet rule. It has to satisfy the octet rule. So what's going to happen is carbon, oxygen, is going to be a pal and take one of its lone pairs of electrons and share it with the carbon. Like that. Now, each oxygen is going to have to do that because carbon needs to touch 8 electrons. Now, something else that I saw people doing, they would make the double bond, but they wouldn't get rid of the lone pairs. Oxygen is sharing a second set of electrons, a second pair of electrons with the carbon. So you need to make sure that you erase one of the lone pairs from the oxygen when you make the double bond. It's going to make something that looks like that. Now there was confusion because carbon dioxide, the shape is going to be linear because there are only 2 branches around the central atom. They're going to try to get as far away from one another as possible, and so as far away as they can get would be 180 degrees, and that's going to give it a molecular geometry of linear. People would draw things, though, like OCl2. And that would look something like this. Oxygen is going to be the central atom. It's going to be bonded to each of the chlorines. Then there are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons distributed like that. Now, in an OCl2, there can be 20 valence electrons. So right now I've used 8 around this chlorine, 8 around that chlorine, so that's 16. So I still have 4 valence electrons to place, and I'm going to place them around the central atom. And that'll satisfy oxygen. It'll satisfy the octet rule for oxygen. Now, will this molecule, the OCl2, also be linear like our carbon dioxide? Well, at first glance, you think, yeah, it's going to be a line. Look at how I drew it. We've got a bond there and a bond there, and so why won't it be linear? Because these lone pairs around the oxygen are going to repel the 2 bonds, and so it is going to mush those bonds down closer to one another. Here, you have all the room in the world to move because there are no lone pairs around the carbon. In this molecule, you don't have all the room to move in the world because the lone pairs are going to repel the bonds. And so, when you have 2 bonds and 2 lone pairs, that gives you a molecular geometry of bent. And the angle in 3 dimensions, the angle between these chlorine bonds is going to be 105 degrees, give or take. So we need to make that distinction. Bonds and lone pairs, bent. Just bonds, linear. So I hope that helps. I hope that keeps you from making a mistake, but that depends on a lot of things. So.